The architecture components lifecycle library is designed to help you solve common Android lifecycle headaches and to make your apps more maintainable and testable. This here is an introduction to the LiveData and Lifecycle classes. LiveData is a data holder class that is also lifecycle aware. It keeps a value and allows that value to be observed. Now, a primary use case of LiveData is to update the UI. You'll have a model object, such as this user object, which is wrapped by LiveData. Then you'll have a UI component, like an activity, that will observe a LiveData. When details of the user LiveData change, the activity is notified and it updates its UI. LiveData makes it easy to keep what's showing on screen in sync with the data. So let's take a look at the code. LiveData objects will usually be kept in the viewModel class. If you're not sure what a viewModel is, you should check out this video. You will always define the type of object the LiveData holds here, and it can be any object type. Next, in the onCreate of the activity, you make an observer object. The onChange method defines what happens when the LiveData object actually changes. In this example, the method updates a text view of the activity. Then all that's left is to have the observer subscribe to the LiveData to receive updates. If you observe a LiveData object that already contains a value, your observer immediately gets notified with that value. Once observation starts, when the LiveData is updated, the UI will automatically update. What makes LiveData different from other observables is that it's also lifecycle aware. Now, to understand what this means, though, you first need to know about the Lifecycle class. A lifecycle is an object that defines an Android lifecycle. Relatedly, Lifecycle Owner is an interface for objects that have a lifecycle, and a Lifecycle Observer is an interface for observing lifecycle owners. As of Support Library version 26.1, both Activity and Fragment implement Lifecycle Owner. These classes provide ways for you to both query the state of a lifecycle and to receive callbacks for lifecycle events. LiveData leverages this. When a LiveData observer is created, it is associated with a lifecycle owner. Observer objects are then only notified of their updates if their associated lifecycle is in the started or resumed state. Observers also automatically remove themselves when their lifecycle owner is destroyed. LiveData is therefore protected against accidentally updating a UI component that's in the background or destroyed, without you having to do anything extra. So how is LiveData actually updated? SetValue and PostValue are two methods for updating LiveData. Use SetValue if you're running on the UI thread, and use PostValue if you're running on a background thread. Additionally, Room and LiveData go together like peanut butter and jelly. Room can return LiveData objects which are automatically notified when the database changes, and have their data loaded in a background thread for you. This makes it very easy to have the UI update when your database updates. You can learn more about Room in the Introduction to Room video. While we're on the topic of updating LiveData, let's talk about encapsulation. You'll usually work with LiveData and mutable LiveData. Now, as the name implies, mutable LiveData is mutable. It exposes the setValue and postValue methods. LiveData, on the other hand, is read-only. In general, your viewModel should be the only class directly updating LiveData. This means that within the viewModel class, you can use mutable LiveData, and then from the outside of the viewModel, you can expose plain LiveData objects. As your LiveData expertise increases, you might find that you need to manipulate your LiveData. You can use built-in transformations, or you can make your own. The built-in map transformation lets you apply a function to the output of one LiveData and then propagate the results downstream to another LiveData. In this example, whenever the user LiveData changes, username is notified, runs the map function, and then emits the resulting full name. The switch map transformation is a lot like map, but instead of the mapping function emitting a value, it emits an entirely new LiveData. An example use case is if you have a bunch of users, perhaps stored in a Room database. You could use the switch map to change which user you're actually observing. You'd input the ID here. Then you'd need to provide a function that returns a user LiveData given that ID. That function could then emit a totally new LiveData, but you wouldn't need to update the observers. Here's the code, with a LiveData for updating the ID, a function that takes that ID and outputs the related user LiveData, and the switch map function. If you want to make your own custom data transformations, you should take a look at Mediator LiveData. Mediator LiveData includes methods to add and remove source LiveData objects. You can then combine and propagate events from all of the sources downstream. One use case is if you want to display a LiveData object that could be updated either from the local database or the network. You can take two sources and add them to the Mediator LiveData. The first source would be a local database LiveData object, and the second source would be a network LiveData object. Then your activity would only need to observe the single Mediator LiveData object, but it would receive on-change updates from both of these sources. Getting started with LiveData is simple, but there's a lot of room for potential experimentation with this lifecycle-aware observable. Hopefully, this has inspired you to build something, and as always, the documentation is linked.